I'm able to come and talk at these sort of functions through the support that I'm getting through the Department of Primary Industries and GRDC. Without their support, we wouldn't have the cereal pathology work that me and my team are doing, which is hopefully providing support to you to help your growers manage diseases. The stuff that I'm presenting today is really talking about a range of issues in diseases, what are the issues for this year, and some of the updates on some of the work that we've been doing. And a lot of what I'm presenting is also relying on the work that we do with our colleagues in South Australia and elsewhere in Victoria. So as I said, there's a number of things I'm going to talk about, and I'm very keen that we have some time for questions at the end, so we'll be skipping through these pretty quickly. And when we're talking about disease management, we are talking about how we're managing our risk. Now, if we're going to manage risk for disease, we need to understand the risks. Now, we do know that we can effectively manage disease. We only put a cereal crop in a paddock once every 3 or 4 years. We use multiple applications of fungicide, and we use the most resistant varieties we can. That will give you complete disease control, probably send your growers broke, but we can manage disease. If we are going to do it in a profitable manner, we need to understand the risks that are associated with the diseases so that we're managing disease risk in the most cost-effective way. If we're going to manage the risks, we need to understand what they are. Now, if we're going to get disease developed in a paddock, we need several things to come together for that to happen in a crop. We need our inoculum source, and that can come from seed, out of the soil, off stubble, or off other plants such as volunteers. We need a susceptible host, so we need to understand the varieties that we're growing. Final thing we need is the right climatic conditions. And when we're looking at the diseases we're managing, we need to understand, well, what are the conditions that favour those diseases, so that we know when we have to manage diseases and when we don't have to put expense into managing diseases. Overall, so we can manage the risk. So what are the risks of 2013? So probably a big one that we've been dealing with for the last couple of years has been the inoculum carrying over on volunteers, or the green bridge. But in contrast to where we were in 2011, as you see by that photo, where we've had a couple of wet summers and we've really been pushing the rust management message, we just don't have the inoculum source this year. A dry summer reduces the amount of rust inoculum that's going to carry over, and it takes us back to where we were a few years ago before we were having the wet summers. So we can adjust our management of rust accordingly, knowing where the risk is at the moment. Stubble-borne diseases are important for things like yellow spot, net blotches and scald. And that's really on a paddock-by-paddock basis in a lot of cases, looking at, do we have 1 or 2 year old stubble in that paddock? Are we putting a susceptible variety in there? Soil-borne diseases, not as easy to pick whether you've got a soil-borne disease issue. Unless you've seen a history of it in that paddock, you're really relying on conducting some soil tests prior to planting so that you can fully understand the risk that's in that paddock, and we're going to talk about a bit more of that as we go along. Understanding your variety susceptibility, seeing where the weaknesses are in your variety so that you know what are the potential diseases you have to manage, and putting in place the appropriate management strategy. And then rainfall, seasonal conditions is very important for the development of disease. And we need to understand how they're impacting on disease. So if we get exceptionally dry seasons, we don't need to put as much work into our rust management. The wetter it gets, the more effort that we have to put in there with our fungicide strategies. So just a quick word on rust. I'm not going to talk much about it because, as I said, rust survives from one season to the next on volunteers. It has to survive on living plants. When we've got exceptionally dry conditions, the opportunity for it to carry over is exceptionally low. So that means we can adjust our management strategies accordingly. Where in some years for varieties we were putting treatments out up front and being very proactive with our fungicides, you can adjust that profile of how much money you're spending up front. You can, more likely you can take a wait and see approach, see how the season's progressing. But you're going to work that out as you have been with your farmers in terms of how you manage those risks. But it's still very important for the most susceptible varieties that you are very active in the rust management of your susceptible and very susceptible varieties. It's the intermediate ones where you can really make some adjustments in terms of the expense that you're putting in rust. Looking at yellow leaf spot. I guess we're all aware that it's a very common disease in wheat, especially where we've got wheat going into wheat stubbles that are 1 or 2 years old. It is a stubble-borne disease. But there's been a real question there of, well, how much is it affecting yield? So there's We see a lot of it out there affecting the seedlings, and then there's always the comments, which I also make myself, well, the crop grew away from it, wasn't an issue. Sometimes we've even made data-free observations that we're probably pruning the leaves with a bit of disease early on helps conserve some moisture so the crop can finish better later on. This has really been the absence of a lot of good data to say, well, just how important is it? For a disease like stripe rust, which is very aggressive, we can apply a fungicide and get complete control, and we can compare the yields that we're getting with and without fungicides and say, well, this is how much damage that disease is causing. As we look at the crops, we know that yellow leaf spot's not causing huge amounts of yield loss, so it does get harder to measure those smaller amounts. Like, you can't look at a paddock and visually see a 5 to 10% yield loss. Very hard to pick it up in research. But one of the challenges for working with yellow leaf spot and estimating how much yield losses are causing is the fungicides have marginal effect. This is using some data with and without fungicides that we gathered in collaboration with the Birchip Cropping Group at Combatal this year. And you can see that fungicides have reduced the incidence of disease, but that small reduction is not enough that we can measure the benefits of or the effects of yellow leaf spot on grain yield. It's only when you can see the level of control you're getting the more resistant varieties versus those susceptible ones. So when we get partial control with fungicides, it makes it harder to estimate yield loss. Another way of doing it is looking at a large set of varieties with different reactions to yellow leaf spot. And this is some data that was collected nearly last century in 2001 in an NVT trial. And we could look at how groups of varieties, a number within each category, and what effect they're having on yield. And that gives us a bit of an estimation of the extent of yield loss that yellow leaf spot may be causing. It's not conclusive. This is really where we're heading. We need to establish just how important is yellow leaf spot in the cropping system with what we're seeing. Move forward to 2012. Again, looking at that trial that I showed with the fungicide data that Birchip conducted last year, where we've got a range of susceptibility and different levels of yellow leaf spot, and then the effect that what we're seeing in terms of grain yield. And again, there's a difference around that 10% area, similar to what we saw before. Now at this point, you can't say that this is a definite, but it's starting to look like, well, this is the general indication we're getting. The difference, if you're going to plant a variety into a wheat stubble, there are advantages of growing something that's got more resistant than the more susceptible ones. And some of you will look at this and say, well, these varieties down this end, the moderately resistant ones, these are the new varieties, so clearly they're going to out-yield the more susceptible varieties. So it's only to do with yield advantage of the different varieties, but what I have done is looked at the long-term yields of the varieties that were in this experiment, and basically they're all the same right across the categories. So looking at long-term yield is suggesting that yellow leaf spot is having a part there. Something we need to do more work on, and that's what we are going to be looking at. But I think we're starting to get a message there that if you're putting wheat into wheat stubble, really look at the options that you have in the more resistant varieties there and avoiding the most susceptible ones. But I think there is a yield penalty when you're growing very susceptible crops into infected stubble. Crown rot, 2012, if you're going to write a recipe for crown rot, you would have a wet start to the season followed by a dry finish, and I think that's really what we saw last year, and we saw lots of crown rot out there. This photo is what we saw in the Birchip area last year, pretty typical of what was out there in a lot of crops. Now, unlike a lot of foliar diseases we deal with, once you get signs of crown rot in your paddock, there is nothing you can do about it. The management of crown rot has got to happen at the time that you're deciding what's getting planted in that paddock. And that's where soil tests come in. Now, in terms of the soil testing that a lot of you would have been involved with and done training in the root disease testing service, or the Predictor B test, in the scheme of things, that's relatively new technology. It's only in recent years that we've had access to a test for crown rot, and we've been very active in doing work with that test to establish, well, just how important is that, and what does it mean for growers in southeastern Australia as predicting the risk of crown rot so that you can implement that in your management strategies. So we've just published in the last couple of weeks work on 26 data sets And this has gone into published in Americas because it has worldwide significance, that we've shown that we can look at a range of crown rot levels as measured using a soil test and looking at the amount of DNA there and how that relates to yield loss in wheat. So this is telling us that we can use the soil test as a good indicator of the amount of risks that we have to crown rot. But as we know, that seasonal conditions are very important for deciding, well, how much risk is associated with different levels. And the results, or the risk, is very much dependent on seasonal conditions. And these are looking at those conditions that had below average September and October rainfall versus those seasons. Sorry, I ran the wrong way. These are above average, so wet springs versus dry springs. So it's a really big determinant of how much yield loss you get. The other thing that this work showed us is that if once we've had a test result, we know that we've got a level of crown rot there, we can change the risk by the cereal type that we choose. If we go into durum wheats, the risk is going to be much greater. If we can move to barley, the yield loss will be lower. And then we can put all that together when we overlay the different seasonal conditions as well. So there's a really powerful tool there in terms of being able to detect identify prior to sowing how much risk there is associated with crown rot, so you can do that before you get to the position of, I've got crown rot and there's nothing I can do about it. So the next question this raises, I do have a medium level of crown rot in my paddock. I've decided that I'm going to grow barley to manage my levels, but what am I going to do in the long run? Because ultimately we need to reduce our inoculum levels. I'm working with our colleagues in South Australia. We did a number of years of work across Victoria and South Australia, looking at rotational crops and what effects they have on crown rot inoculum levels. And basically, crown rot is a stubble-borne disease that is a disease of grasses. So all our cereal crops increase the inoculum levels, whereas our broadleaf crops and pulses, effectively canola and fallow, reduce our inoculum levels. But it's important to note there that what we've found is that you're really going to need a 2-year break from cereals in most cases to get your inoculum levels down. That raised the question of, well, could we have a 1-year break and include some stubble treatments in there? This was done in 2006. As you can see, we didn't have a huge amount of stubble in these treatments, but looking at a range of options there. So the burning is the black versus this light green, which is basically a standing stubble. There is a reduction. Here's a non-significant reduction. That reduction is quite small. So burning in a 1-year break scenario is having a small effect, but we're not getting huge benefits out of it. So we're not really actively encouraging burning. It does have some effect, but it's not a huge effect. The effect of the burn, the hotter the burn, the more ability to burn into the crowns is going to give some better control. But in this experiment, the low levels, you're talking about getting the bars down to here. So that's it for crown rot. Following the same theme is looking at root lesion nematodes. Again, another soil-borne disease, and also where we've been working with the predicted bee test to establish, well, how does that relate to predicting the risk of yield loss and what sort of yield losses do you get from these nematodes? So same as I was talking about before, we have established a range of levels of root lesion nematodes in the soil as determined using that test, and looking at what effect that has in a range of cereals on yield loss. So this information will help you when you get a test result back to get some estimates over a range of seasons of what range of yield loss can you expect, and then what are the relative tolerances of varieties. So we're trying to rank varieties on their tolerance so that hopefully by next year the disease guides will again have tolerance ratings in there. Currently we don't have tolerance ratings because we've had a lack of data, but we are now in a position where we're starting to be able to include that data again. And as you can see within Derrimut, Yippy and Cara, there are differences in their tolerance. And then we're looking at Catalina and Hindmarsh at the top there. Now those increases in yield are not significantly different to zero, but there is something going on where we're seeing in more than one season where yields have slightly increased in the presence of high nematodes. So there are crop options that we can use to minimise losses versus some things that we should avoid when we're looking at managing root lesion nematodes. The other thing about managing, once we know that we've got a paddock which has got yield limiting or yield affecting levels of nematodes there, what can we do to manipulate those nematode numbers? And that's where we grow a range of varieties in the field and look at the effects that they have on the nematode numbers. So we've got the varieties running down here, and this is the nematode population, and this is a log number so that you can actually see the error bars on there. We can't put the statistics on the raw data, but the raw data is there, shown there so that you can see what actual effect they're having on numbers. And that's looking at the starting population. So you can see that varieties vary in whether they're reducing the population, maintaining it much the same, increasing it by a bit or increasing it by a lot. Now this is just looking at one trial. We're combining data from a range of sites and a number of trials to come up with ratings, but we're able to group varieties and then assign ratings to them, and that is what is getting put into the disease guide. So that's how you can understand what our ratings for resistance means to these nematodes. In terms of the intermediate ones, maintained population is much the same versus the more susceptible ones that are resulting in significant increases in nematode numbers. And as I said before, the more nematodes that you have there, the greater potential for yield loss depending on the varieties that you're growing. Moving back out of the ground and looking at some work on barley diseases, and this is what my colleague Mark McLean with Horshams been working on, is looking at some of the impacts of scald, which has become or reoccurred as an issue over the last 3 years in Victoria, and getting an understanding of just how important is that disease. And what he's finding here is where there's no control of scald in the experiments versus complete control, yields are reduced by around about that 1 tonne in the most susceptible varieties. It's also been looking at a range of management strategies there. So you can see there's a list of different upfront treatments and different timings of fungicides. Now, the information here is presented in the book. But basically, when we're in a risk scenario, the key for it is there's a range of options you can see, whether you use impact or foliar fungicides. It's not so much which one of those you use, as long as you use something and you use it before the disease gets out of control. If you leave it too late, you can't bring it back. So you could spend a lot of time arguing, should I use impact, should I use a spray up front? The main thing is when you're seeing that disease getting going, hit it early. If you've got a susceptible variety, the right conditions, get in there early and you will get good control. If you let it get out of hand, then it's really hard to play catch up. And again, it's understanding those risks that are associated with scald, what the season's been, what the varieties, what your inoculum is out there, and getting out and monitoring. Nephform and blotch, it's a disease we haven't seen a lot of in barley in Victoria. Now the main reason for that is that we've been growing varieties that have adequate levels of resistance. Where we do see nephform and blotch is where we get varieties that are susceptible when grown, and we've been seeing some of that in Fairview. If we move our varieties from what we're growing at the moment, where we have adequate resistance to the more susceptible ones, this will become an important disease. And I think nephform and blotch is a good example that leads into the next slide, is that where you can have long-term control and sustainable control of diseases if we avoid the susceptible and very susceptible varieties. We keep those suckers out of the system and we put downward pressure on our inoculum loads, which means we just can really move disease away from being an issue. So susceptible and very susceptible cultivars, they create disease situations where you otherwise wouldn't have one. And I think looking at trial results from a Birchett trial that was conducted at Horsham last year, looking at a range of varieties and their susceptibility to strike rust, only the susceptible and higher were the ones that had an issue. Now the disease, there wasn't a huge amount of disease pressure last year from strike rust with the dry spring that we had, but it was those most susceptible varieties that created the problem. Everything else would have been fine. These varieties are much more prone to yield loss, and really these ratings are related to the yield loss. This is a graph a lot of you have seen me present a lot of times, just showing the potential for, or the relative loss that you get as you move into the more susceptible varieties. And again, some other data. Now, there are increases in the yield loss that you get in those varieties with resistance, but it really gets exponential when you get into the susceptible and very susceptible varieties. I guess as most of you know, the more susceptible a variety, the more costs that you have to put in place in terms of managing those varieties. The amount of inoculum they produce, which again adds to the problem that you have in the next year, the problem that you have within crops and going forward, is related to the fact that the more susceptible they are, the more inoculum that's getting produced. You can see this just with the difference between two leaves with stripe rust on them. The number of spores that's coming off there, it's in a different league altogether, which adds to that epidemic in a district. Or we can go back to that example we looked at earlier for root lesion nematode numbers, intermediate varieties, about 40 nematodes per gram after those in this example, versus up around 150, nearly 4 times the number of nematodes following those more susceptible varieties. So that has impacts that will leave high nematode numbers there, not just for the next year, but potentially the year after as well. And the more inoculum that we have out there, depending on the pathogen, but in general, the more inoculum we have, the greater the chances we have of resistance breakdown occurring. And it's really important that we do all we can to manage the resistance genes that we have. And one way of protecting the resistances we have is to reduce the amount of inoculum out there. The less inoculum, the less chance of resistance breakdown happening. Now clearly, we are growing susceptible and very susceptible varieties. We need to manage them in the risk that they're there. But if you are growing them, be very proactive in making sure that risk is managed and using fungicides to keep those inoculum levels low. So they can be managed, but do that properly so that the risks associated with resistant varieties in terms of the risk to resistance genes, the risk to inoculum build-up can be managed for some diseases by using fungicides in a very proactive and timely fashion. So in terms of disease risk, one of the important tools that you'll be looking at is the Cereal Disease Guide, and that's available outside of the DPI stand. Frank is looking after that. And the disease ratings that are available in that guide are also available in app form, and that is available by searching for the DPI crop disease in either of the app stores that are available. I'll leave it there in the expectation that we might get some questions.
All right. Well, thanks very much for that, Grant. That was excellent coverage of some of the things that you've been up to. Now, there's a couple of questions on the slide over here, so let's take the first one. So, Grant, have you seen any relationship between bacterial blight impulses and stubble retention amounts from previous years? Is that
in relation to cereal stubble or pea stubble? Who asked the question?
Both.
Yeah, I guess in terms of your big one for bacterial blight, it carries over on seed, but an even more potent source of inoculum is on stubble. So if you're sowing into 1-year-old pea stubble that's had bacterial blight in it, that is an exceptionally risky situation. Now there is some interactions with cereal stubbles, and it's to do with the effects of, well, we believe it's to do with the effects of frost, and the effects that the stubble loads are happening on the frost there, because frost is really important in bacterial blight. But it's not something I've looked at in a lot of detail. So which ways it affects it, it is in relation to frost, but I can't speak on that one straight off.
Is there any advancements in variety breeding for crown rot?
Yes, there is progress happening. There are varieties that are coming onto the market that have, there's some improvements in the wheat varieties. There's still a long way to go, but there is a lot of work going on there. So at the moment, the majority of wheat varieties out there are rated susceptible. Now there's a couple that I'd have to consult the guide that do have some improvement for crown rot, and they're coming in rated at moderately susceptible. And in high risk in situations where people have got problems with crown rot, there may be some advantage in moving to those. And I would be expecting that with the work that's going on in the pre-breeding world, that we will be seeing more improvements there. But so there is progress happening, and we're starting to see some better lines coming through, and I think we will see more in the future.
Hey Grant, just a question about yellow leaf spot. Do you have any data with the effect of fungicide on crop yield? I think the data you showed was on leaf severity.
Yeah, so is that question of the benefits of using fungicides for controlling yellow leaf spot? Well, I guess as you showed there, as we saw in that graph, that the fungicides were giving partial control. So, yeah, we don't have a lot of good data that's showing big benefits of using fungicides. So there's not a lot of good information there. But where we want to get to is to better understand what timing we should put on there. We believe that we can get some benefit if we can actually time those fungicides better around when we're getting spore releases. But at the moment, it's a bit of a hit and miss, and yeah, there are benefits there, but it's not as big as we'd like it to be. So the fungicides don't provide the only answer.
Just grain more on yellow leaf spot. There didn't seem to be that much drop off in the amount of yellow leaf spot from the 2-year-old stubble to the 1-year-old stubble. We got belted by yellow leaf spot again this year, and we didn't have any wheat on wheat. It was wheat on previous years, 2 years back stubble.
Yeah, definitely for the spot form and net blotch, yellow leaf spot, those diseases, it's stubble that's 1 and 2-year-old is the real issue. How important is 3-year-old stubble? It depends on how much breakdown you've got. And in some cases we've seen where 2-year-old stubble is a lot more potent than 1-year-old stubble. Is what we're seeing through the dry years. So it does depend on the conditions. Now I don't fully understand that. We're about to start some work with, well, South Australia have been doing some work, but we're about to get involved in that as well, where we're looking at spore release off stubble and how that relates to weather, so that we can actually better understand the climatic conditions that are supporting the development of spores coming off the stubble. So we've about to take, we've got spore traps coming from England at the moment that we'll be using to monitor release and try and relate that to weather. Then going forward we can start to also look at the relative effects of different ages of stubble.